Okay, the good news is I'm not going to give you a difference quotient that has a cube. Okay, it will have a squared, but it won't have a cube just because of time purposes alone. But if you, obviously, let's review how to do it because this is the difference quotient itself will be a question on your test, which is a week from tomorrow. Okay, so first of all, I know my difference quotient is given to you here. It will not be given to you on your test. You have to have that memorized. So if I take that f of x plus h, I plug it in, I am going to get 9x plus h cubed plus 8x plus h. I would say most people don't have the cubed shortcuts memorized, and sometimes I think it's just as fast to do like the squared shortcut with just one. So that's what I tend to do, which I know is x squared plus 2xh plus h squared, and then I would multiply that times x plus h. And then we're going to distribute. So the x goes to all three. I get x to the third plus 2x squared h plus xh squared. Then I do the h to all three, and I get plus x squared h plus 2xh squared plus h to the third. And this time you have terms to combine. X to the third is by itself, but you have a 2x squared h and just x. Oh, no, not that one. That's that one. Plus 2x squared h. You have an x h squared and an x h squared. This should be, sorry. This should be x squared h. That's this term. So that you do have two to combine. So those two, we give you 3x squared h, and then there's also a 3x squared 2, and then plus h to the third. So that's after that's just cubing it. Then we'd have to multiply the whole thing by 9 because of the 9 on the front here. So I'd get 9x to the third plus 27x squared h plus 27xh squared plus 9h to the third. Then I distribute the 8. So plus 8x plus 8h. And that is your f of x plus h. Then from that, you're going to subtract the original. I'm just going to change the signs instead of minusing and then distributing. When you change the signs, you get minus 9x to the third minus 8x. If you've done it correctly, you've got a positive 9x to the third, a negative 9x to the third, they cancel out. A positive 8x and a negative 8x, they cancel out. And then I put everything else over h. And if you've done it right, the h should cancel in. That's 1h there, 1h there. This becomes squared, and this h is gone. So I have 27x squared plus 27xh plus 9h squared plus 8. The order does not matter. Like if you check your answer, it puts the h squared first. I don't care about the order. As long as the signs are right, as long as the terms are right, you could leave it like that. You don't have to rearrange it.
It won't be like that on the test.
It won't be cubed. So you will have a squared, but it won't be cubed. Yeah. Yeah.
Is there going to be a partial credit on the AP test?
Yeah, as long as it's open-ended, it's partial credit. When we get to multiple choice, obviously no, but there will be. So, and on the AP exam or the AP from me, both are partial credit. So like you have 4 free responses, 2 with a calculator, 2 without. And those free responses have multiple parts. They usually have like 5 or 6 parts.
That's for the exam, right?
That's for the actual AP exam. Yep. And let's say you do something wrong in step 1 and you carry it through. You will lose the point for step 1, but they let you carry it through. So I try to do the same thing on yours. So let's just say like you made a mistake up here when you were expanding this, but then you used it correctly down here, if that makes sense. I don't dock you both places. We call it a carry through mistake. But yes, on the free response questions, either open-ended that I give you or open-ended that you get in May, that you will get partial credit on those things. Okay, 1-3 is graphs of functions. So we're going to talk about a little bit of stuff that we already talked about. We'll talk about like what is a function, but we're going to use the vertical line test. Then we're talking about domain and range. We're going to learn how to graph piecewise functions. There's a lot of stuff in, and even and odd, a lot of stuff in this section. Some of it will be calculator based and some of it will not. So we start with domain and range, okay? When we're looking at domain from an equation, like if it asks you to find the domain algebraically, then you're just simply trying to use those three things, like it's all real numbers except, and it's the square root in the bottom, or sorry, square root, variable in the bottom, or the two combined. But when you're looking at a graph, which is what we're going to focus on today, the domain is the x values. So from left to right, and the range is the y values, bottom to top. Yeah. All right, so this is also going to be in interval notation. Just like your domain was in section 1, 2, you'll have to write this in interval notation. So I'm going to, from my domain, I'm going to go left to right, all the values that my graph covers, and range bottom to top, all the points that my y covers. Things like arrows going off the graph is going to be positive infinity or negative infinity, depending on which direction that they point, okay? If it's an open dot, then it gets a parentheses. If it's a solid dot, it gets a bracket. So just like we do on the number line. The next thing it will say is find the indicated value. So it'll say like find f of 2. And think about what that's asking for. The 2 represents the x, right? So it's basically saying find y when x equals 2. That's the same thing. So you'll go to your x value and you'll give the corresponding y. You can be asked to do this from a graph without a calculator, and then you can be asked to do this, it might say like graph this function and then find the following. So if you had the equation, you could also plug in your value for x, but you will not always have the equation. Sometimes you just have the picture of the graph. All right, example 1 says find the domain and the range, and then find the indicated function values. So before we even get to a and b, we're going to do domain and range. So domain goes left to right. What's the furthest point left that is graphed on this function? -4. This would be -1, -2, -3, -4. Okay, so it starts at -4. Is that a solid dot or an open dot? Solid. So we count it, which means it gets a bracket. What's the furthest point to the right? -1. And is there any stops along the way? No, it's one solid line. It's also a solid dot, so it gets the bracket. Then for range, we're going bottom to top. So this would be -1 and -2. What's the lowest point? -2. It's a solid dot, so it gets a bracket. What's the highest point? +2. Would this be considered a solid point?
No. Yes.
Yes. Unless it's literally an open dot, we consider it to be a solid dot. Okay, that line is a point on that graph. So it goes to +2 and it also gets a bracket. Okay, now we want to find the indicated function. So f of -4, I go to -4, I find the coordinate point, and what was that as my y value? -2. So we just write -2. You don't write y equals -2, you just write -2. How about f of -1? 1. Question so far? All right, now we're going to use the graphing utility. So you want to get your graphing calculator out, and we're going to graph this function. If you don't have your handheld with you today, you can use the app, but I would strongly recommend that you make sure you put that handheld in your book bag and start bringing it every day. All right, so I'm going to type it. I went to y equals, and I'm going to type it in. Remember that absolute value is under the math menu. So I go to math, and then I arrow over 1 to the NUM, which is the number menu, and I hit enter on ABS, and it gives you your absolute value brackets. And then I'm going to do x plus 2, hit enter, hit graph. All right, and then it said, let's figure out your domain and range. So think about your domain. What's happening furthest left, furthest right? -infinity is my furthest left, and my furthest right? +infinity. Both of those lines get cut off by the edges of my screen. No matter how far I zoom out, it still would continue, right? So domain, -infinity to +infinity. How about your range?
0 to +.
Good. The lowest point here is 0. So it goes from 0 to +infinity. All right, so we said domain would be negative infinity to positive infinity, and range would be 0 to positive infinity. And it gets a bracket because that point is included on your graph. Yeah. Did you put the second part says verify the result algebraically. So if you think about what was our test for domain algebraically, what did we do last week when I gave you an equation and said find the domain? What restricts domain on an equation? Variable in the denominator. Is that happening? No. What else? Variable in the square root. Is that happening? No. Combination of the two. It's not happening. So there's no restriction on this, which is consistent. Okay. So when it says verify algebraically, the test would be for domain. All right. Now we get the vertical line test. So yes, on Friday we talked about, and Thursday we talked about how do we know something is a function based on the equation and based on the points. So on points, the x can't repeat with a different y. On the equation, the y can't be in the absolute value and the y can't be raised to an even power. The visual test is called the vertical line test. If a vertical line hits your graph at more than 1 point, then it fails your vertical line test and it is not a function. This actually appeared as a part of one of the FRQs on the AP test. I think it was on one of the practice tests or the actual one, I don't remember. But the question was, is it a function? And the answer was no. And it would say and then it would say explain why. And it would say you cannot just say because of the vertical line test. You can't say it fails the vertical line test. So you would say something like each x is not mapped to a unique y. So each x must be mapped is the word they use to a unique y. And they even went further and said x, which is input, and y, which is output. This is when language gets tricky, and this is the difference between a pre-calc honors question and an AP pre-calc question. They want you to talk it out. They want you to know it so well that you can explain it in math words, okay? So they use input and output instead of x and y, and they talk about the points being an x goes with a y is like that mapping. So each x has to be mapped to a unique y. It cannot be mapped to two different y's. All right, so example 2 says use the vertical line test to determine whether the curve of the graph is a function. If it is, state the domain and range of the function. So I'm going to start with A. Is A a function? Yes, no matter where I draw a vertical line, all those vertical lines only hit that graph at 1 point, right? So it is a function. And so what is the domain of this graph? Because it continues on, we assume those are points that stop. If the edge of my graph was here, then I assume that it's going to continue. But because there is space to the left and right of them and it doesn't continue, we assume it stops. So what's the smallest x? 0. And what's the biggest x? 4. And range? 0 to 3. Good. All get brackets because there's no open dots. Go to B. Does this pass or fail your vertical line test? Fails. Even just one line, even if it was just one part of my graph that a line hit more than one time, it's no. So not a function. Still good? Yes? All right. Finding the zeros of the function. We did this last week, except that it said find where f of x equals 0. It's the same thing. Where f of x equals 0, same as x-intercepts. It's the only difference there is the format of the answer, right? An x-intercept we would put in coordinate point form, whereas a 0 we list it. It's also known as a solution. It's also known as a root. All of those things mean find the values of x when y is 0 or when it crosses the x-axis. So if I have the equation, I set it equal to 0 and solve, there will be a lot of factoring involved here. If I have my graphing utility, I can look for where it crosses the x-axis. If I have a graphed picture, I can look for where it crosses the x-axis. All right, increasing and decreasing behavior. So this, when we look at increasing, decreasing behavior, we're looking as we move from left to right. So we go left to right just like you would normally read. If the graph is rising at that point, we call it increasing. If it's decreasing at that point, we call it decreasing. If it's horizontal, we call it constant. These questions will also be answered in interval notation. So if I had a graph that looked like that, then I'd go in chunks. I would say it is an increasing function from here to here, which would be from negative infinity to whatever point this is. Let's just say that's 2. Then it changes to decreasing here. So it's decreasing from 2 to 4. And then it changes to increasing again. From 4 to positive infinity. Now you notice that whole time I'm using parentheses. A point, so like this point cannot be increasing or decreasing, right? It's a point. The only characteristic a point can take on is constant, and that's only if that point is not shared by an interval that's increasing or decreasing. So the only time you're going to see a bracket in increasing and decreasing is if your function starts constant. Even if it becomes decreasing and increasing, this is the only time I would use a bracket. Or if it ends decreasing, ends constant, here, I would also use a bracket. That's the only time you see a bracket on increasing and decreasing behavior. So when in doubt, put a parentheses. Chances are it's less likely that it will be a bracket, okay? And it will not be a bracket here, and it will not be a bracket here because those points are part of 2 intervals. On one side, it's constant. On the other side, it's decreasing. On one side, it's increasing, and the other, it's constant. And a point can't be both constant and decreasing or constant and increasing. So again, it is almost always parentheses on increasing and decreasing behavior. These are also questions that show up on the FRQs. Like this is stuff we will continue to do all year, but it will definitely show up. All these function things show up on the FRQs. All right, max and min. So a relative max is any peak in the graph, which means it could happen more than once. And a relative min is any dip in the graph. So my graph can go up and come back down again and go up and come back down again. And both of these would be relative maxes. And then even though it points down in both directions on the left and the right, that green dot would also be a relative minimum. We will eventually get to absolutes, and absolutes there can only be one. So an absolute max is the highest it goes, and an absolute min is the lowest it goes, okay? Those are different. Relative means it can happen more than once. All right, so this one says, use a graphing calculator to graph it, then identify the relative max and min. Oh, do you have a sign in between your? I don't know why mine's missing it. It says negative 2x squared. Does yours have a sign there? Minus 9x, thank you. All right, we're going to graph it. Okay, so I graphed my function, okay? This is my negative, and make sure when it's the leading one, it has to be this guy, it has to be this minus, or you'll get an error, okay? So negative 2x squared minus 9x. When I hit graph, it's a parabola, which makes sense. It's an x squared, right? That's the highest exponent. But at the very top, it gets cut off. So I have 2 options. Do I want to zoom, and I go to zoom out, and I hit enter again, and I zoom all the way out? Or do I want to just adjust my window? So I could go to window, I could go back to the negative 10, 10, negative 10, 10. And my x was fine. I got the whole thing from left to right. I just needed a little bit more room on the y. So maybe I just go negative 10 to 15. And I just give myself a little bit space on the top, okay? I want to make sure I see it go up and come down. You don't want it to get cut off on your screen. Now, do you remember that menu that we used for zeros, right? We did it last week. We're going to use that for max and min. It's second trace. We used 0 and value last week. Now we're using max and min. If it goes down and comes back up again, I would hit min, but it didn't. It's going up and coming back down again, so I'm going to do maximum. Remember how it said the zeros? The first question it asked for is the left bound. So I have to go to the left of my max, anywhere left of it. I have to go to the right of my max. So you can watch your y values change from increasing to decreasing. And then I have to hit enter to hit guess. And my maximum coordinate point is negative 2.499, which would round to negative 2.25. And my maximum y is 10.125. And remember, we use 3 decimal places. All right, so if it just says find the relative max and min, right? If there was more than one, obviously we'd list it, but there was only one max here. So my relative max, I'm going to give the coordinate point, which was negative 2.250 and then 10.125, okay? You'll never lose credit if you don't include that last 0, like it's an insignificant digit. But just keep in mind that you should be rounding to 3 decimal places. Yep.
Once you zoom in, how do you like zoom back out?
So there's 2 ways to zoom back out. You literally can hit zoom and go back out, like click out twice, or go to your window and set your window to the standard, which is negative 10, 10 on the x max and min, or min and max, and negative 10, 10 on the y min and max. You're welcome. So if this also, let's say it had come up and come back down again, then I would include my relative max and my relative min, okay? You have to pay attention to the wording here. So because it said it just said find the relative max and min, I'm going to give the coordinate points. If it had said what's the maximum y value on that point, then I would only give the y value. If it said at what x value does the maximum occur, now I'm going to give the x value. So again, you got to be specific about it if it asks for it. Does that make sense? Okay. All right, now let's talk graphing piecewise functions. So on Thursday and Friday, we talked about how to evaluate these. Now we got to know how to graph them. So remember, they're going to be divided into parts. Piecewise says use this for this part and use this for this part. I'm going to teach you 2 ways to do this. You choose which way you do it, okay? The first way is I can graph them separately. So I can say this is one graph and this is the other graph. So in this equation, that's a y equals 2x plus 3. That's a line that goes through positive 3 with a slope of 2. Up 2 to the right one, down 2 to the left one. And I can draw my line. So I could draw my full line. And then go to the specified points in which I want to keep this for. So it says keep this graph for the values of x that are less than 0. That means it's actually going to start where x is 0, which is this guy, and less than says go left. So it's going to be only those values, and I'm going to erase everything else. Even in here, because it said less than and not less than or equal to. Then I can go to the next one, which says y equals 3 minus x, which would be y equals negative x plus 3 if I put it in slope-intercept form. And I can put a positive 3 and then my slope down 1 into the right one. This would be the whole line if I went the whole line. And then I would go back and say, now I want it for the values that are greater than or equal to 0. So I can erase everything before it and only keep where it's greater than or equal to 0. This time it said greater than or equal to, right? So I use a solid dot. And that solid dot overtakes the open dot. Questions on that method? So graph it, erase it. That's one option, okay? The other option is plug in your points. If I'm going to plug in points, then I'm going to start with the one in which my interval starts with. So in that case, I would plug in 0. I would make like a little T-chart. I would plug in 0, and then I want it to be less than 0. So I would plug in -1, -2, and then I would find my y values and plot them. I still start with 0, even though it says not equal to, because I need a dot there. I just need it to be an open dot. And then I would do the same thing for here. Now I'd start at 0, and I'd plug in values greater than 0. And then I'd get that side of my graph. I would probably recommend that second method if you don't know what your graph looks like. But if there are lines, hopefully it's easier to do it the first way. Like use your slope and your y-intercept. But if it's a parabola or square root or an absolute value and you don't know exactly what it looks like at those points, then the plotting of the points is what's going to help you. Sure. Questions on that one? All right, so try this. Sketch the graph of the function. The first one is that y or f of x would equal 2x plus 1. And the second one is that x squared minus 2. All right, so I'm going to kind of blend together the two methods because I would say the line, hopefully this is easy to draw. If I'm drawing 2x plus 1, I'm starting at +1 and I have a slope of 2. So up 2 to the right 1 or down 2 and to the left 1, and this is what my line looks like. But I only want it for where it's less than or equal to -1. So I'm going to go to where the -1 is, which is here. And I would go down 2 and to the left 1, or yeah, down 2 to the left 1 from there. So this part of my graph is what I would keep for the first part. And then I would get rid of all the rest of it. And it's or equal to, so it's getting a solid dot. Now the next part, x squared minus 2, which we're going to review like all of the parent functions tomorrow and shifts and all that stuff. But let's say you don't remember what this looks like exactly, or you don't know those points. If I knew at least it was a parabola, I could get the overall shape. But what I could do is just take my -1 and plug it in, and then I want it to be greater than that. So I'd go 1 and 2. If I plug in -1, I get 1 minus 2, which is -1. So at -1, I get -1. That would have been an open dot. And then I get 0 squared minus 2, and it's -2. At 0, I get -2. And at 1 squared minus 2, I get 1 minus 2, which is -1. And it's a parabola, so I know this shape is eventually happening. Now, if I just graph this, it doesn't matter that this is solid or open because the solid no, it does matter that it's not open, but the solid overtakes the open dot. But let's talk about what would happen if this was separated out. Let's say that I had a graph that went from here down and then here that way. Why is it important that one of these is an open dot and one of those is a solid dot? What do we call these things? They're piecewise functions. If those were both solid dots, what happens? It's not a function. Why wouldn't it be a function? It fails your vertical line test. So if you have an overlapping x value, one must be open and one must be solid. Does that make sense? If the x values are the same.
Does it matter which one?
Well, it would be whichever one does not have the or equal to. Yep. But be really careful with that. Questions on piecewise? Okay. Last thing in this section is even and odd. So there are two ways to test if something is an even or odd function. This is also something that's on the FRQ part of your AP exam, okay? An even function is symmetric to your x-axis, which means if I take a -x and I plug it in, it should go back to the original. So this would be something like f of x equals x squared plus 2, like the one we just had. If I plug in a -x, it would go back to the original. And that would be even. An odd function would be symmetric to the origin, which means if I plug in a -x, it's going to change. This means change the signs. So if I had f of x equals x to the third plus x, for example, and I take a negative x and I plug it in, I end up with negative x to the third minus x. Both my signs have changed. That function would be odd.
But if only one of the sides.
Then it's neither.
Okay.
Yep. All right, and then if I'm looking from a graph, so I said this, but this isn't in words. If it's an even function, it's symmetric to the y-axis. I could fold it like a hot dog, left to right, and it will overlap. So if you think about that parabola, this would be an even function. An absolute value would be an even function as long as they're on the y-axis. And an odd function is going to have symmetry in respect to the origin. So like our cubic function would be odd because it's symmetric to the origin. So we have symmetry to the y-axis, symmetry to the origin. What are you missing that we've done already? Symmetry to the x-axis. Think about why that can't happen in a function. What does symmetry to the x-axis look like? It would be sideways. I'd fold it top to bottom. What's going to happen if I do a vertical line test there? It will fail. So a function can never have x-axis symmetry. So it can't. It would fail it. Does that make sense? So if we narrow it down to the function, then we only test for even and odd. Even, y-axis, odd, origin. Think like odd and origin both start with O. Hopefully that helps you remember which one's which. And it can never be symmetric to the x-axis. So if it's a function, we wouldn't even test for it. All right, let's put all the last things together. It says graph the function and determine if the function is even or odd, and the intervals for which f of x is greater than or equal to 0. And this one says use a graphing utility to verify. So the first thing we're going to do is graph it by hand, and then we're going to verify, okay? So what if you use your prior knowledge? 4 minus x squared is what kind of graph? Parabola, okay? If I don't remember my shifts, which hopefully, again, we're going to review them tomorrow, but this is a shift up 4, and it faces down. If you know that, it eliminates a point already because I can already go like this. I know it's up 4, and I know it faces down. The rule of parabolas is if there's no like vertical stretch on here, I go out 1 and left 1 in both directions, or down 1 and out 1 in both directions. But because I need to know where it's greater than or equal to 0 on this question, I need my intercepts. I need to know when it crosses the x-axis. So if I find my x-intercepts, I make y 0. I would get x squared equals 4, and x equals plus and minus the square root of 4, which is 2. And that gives me enough to graph this. Even the top 3 would have been okay to get an estimate of your graph. But if we're talking about intercepts, which we need to answer the second part of this question, I have to have the x-intercepts. Question on your test that you graph by hand will ask for x and y intercepts and symmetry, just like we did in C2, okay? So is this function even, odd, or neither? It's even. I know it from looking at it, and if I plug in a negative x, it's going to go away because I square it. So both tests, it would pass. And then the second part of it says, for which interval is f of x greater than or equal to 0? What does f of x represent? Y. So I'm looking for where the y values are greater than or equal to 0. Visually, what would that look like? Everything at the x-axis and above the x-axis, right? So the interval on this graph that is greater than or equal to 0 is that whole top scoop. Where does that start? -2. Where does it end? +2. And it said greater than or equal to 0, so it gets the brackets. If it had said greater than 0, it would be parentheses. And if it had said less than 0, it would have been these intervals down here. So if it had said f of x is less than or equal to 0, I'd be going from negative infinity to negative 2, bracket, and then 2 to positive infinity. Questions? Okay, and then if we use our graphing utility to verify, if you graph that, f of x is your y. If you did 4 minus x squared, you would see that it crosses through. You would see it crosses through right at 2. And if you couldn't read it, like if you needed this coordinate point, then that would be my zeros. So I would second calc, zeros, and I would trace where those cross through.